Hello everyone, today I will present you my virtual SOHO network project. The objectives of this project are to configure the pfSense router and all of its necessary services such as DNS, DHCP and Firewall, connect the virtual machines to the virtual network, check the connection of the machines, then isolate the traffic between the two machines with aliases and firewall roles. This is the topology of this network. VMnet 0, VMnet 1, 2, and 3 are virtual adapters, but here they work just like switches. We can basically look at them as virtual switches. I have created these virtual switches beforehand in VMware Workstation. To see these virtual switches, we go to Virtual Network Editor and go change settings, then yes. Now we can see all of our virtual switches. VMnet 0 is a bridge connection between the software and my laptop's NIC. Then VMnet 1, 2, 3 are all host-only connections. All of these connections don't have DHCP enabled because pfSense router will take care of DHCP. So we don't need that. Okay, now that I have presented all of these switches, we need to go to the settings of our pfSense router. I must mention that I'm not going to show the installation of all of these routers and operating systems. I'm just going to show how to configure this SOHO network. Okay, here we can see that we only have two adapters, and these are the two basic adapters that show up in pfSense after you install it. We need to add the next two adapters, which are VMnet 2 and VMnet 3. Okay, let's double check. We can see all of our adapters that have been added to pfSense. We have added the adapters. Let's start our router and see how things are looking. I'm gonna pause now and I'll come back when it is open. Okay, our router is now open and we can see the two connections that we have. EM0 for WAN or for access to the internet, and EM1 for LAN. This is the connection between my computer and the router, so that I can access its graphical user interface or GUI. Now I want to configure this router. To do that, I open my browser and I enter the IP address that is shown in LAN. So 192.168.1.1. I go to advanced, then accept the risk and continue. Here it asks me for a username and password. Username is admin, default username is admin, and default password is pfSense. That little beep showed us that we have entered the router. Okay, we go to this hamburger menu, then we go to interfaces, then assignments. Here we can see all of our interfaces. We need to add the two interfaces that I have shown before, VMnet 2 and 3. To do that, we just press add. We press add one more time, and now we can see we have opt1 and opt2. These are the two interfaces that I have talked about before. Let's change them a bit. For opt1, we will enable the interface. We go put the name LAN or LAN from Linux for Linux LAN. Then we set a static IP. Then we go down to IPv4 addresses and we put 192.168.20.1. and it's gonna be a /24. This matches the topology I have shown before. We can see VMnet2 is a subnet of 192.168.20.0/24. This .1 address will be for the DNS of this LAN. Okay, we can save, apply changes, and now the changes have been applied. We will do the same thing for the other interface, op2, enable interface. The name will be WinLAN for Windows LAN, static IP, and just as shown in the topology, we will put this IP address, but instead of .0 there will be .1. So /24 192.168.30.1. Okay, save the changes, apply the changes. And now I have created two interfaces. What we need to do next is to enable DNS service. We enable DNS resolver, then we go down and we say enable DNSSEC support, and we also say DHCP, register DHCP releases in the DNS resolver. We will save this, apply changes, and it's done. Okay, now what we need to do is to enable DHCP for both LANs. So we go to menu, services, DHCP server. Go to DHCP server, we go to LinLAN, Linux LAN, enable DHCP server on Linux LAN interface, and then we need to give it an address pool range. We will give the following address pool range: 192.168.20.100, 192.168.20.200. Okay, now we will save this, apply changes, and we will do the same thing for WAN, enable DHCP, and also provide an address pool: 192.168.30.100, 192.168.30.200. Save and apply. Okay, we have enabled DNS, we have enabled DHCP. Now we need to set some firewall rules so that the traffic can flow between the computers. We go to firewall, we go to rules, we go to Linux LAN, and we simply add the most permissive rule there is: pass Linux LAN IPv4 protocol any. Then we save. We will change this rule soon, but for now it is good enough. Again, pass Windows LAN this time, IPv4 protocol any, then save. Okay, so now we can safely say that we have configured the pfSense router. Before I put a check mark, let's restart the router so we can see the changes in this console. I'm going to restart the router, and when I come back, you will see all the changes. Okay, we are back, and we can see that the changes have taken place. Linux LAN opt1, Windows LAN opt2, and we can see the IP addresses that we have set up. Okay, now what we need to do is to configure the machines, but before we do that, let's do a check mark. Okay, so we've checked the first step. Now we need to connect the virtual machines to the virtual network. Before we do that, we need to go into settings, or to do that, we go to settings, we go to network adapter, and we set it to VMnet 2 host only. This is as the topology shows, this is the connection for the Linux machine. Okay. For Windows, we go into settings and we make sure that we have VMnet 3, and we can see that we have it. Okay. Now we will start up these two machines. I will pause the video and I will come back when the two machines are up and running. Okay, the machines are now up and running, and what we need to do is to see the IP addresses that these machines have and the DNS server that these machines rely on. And to do that, we just go to, on our Ubuntu machine, we can go here, then at wire we can go to wired settings. Here in wire we can go to settings, and we can see that the DNS is the address that we have set up earlier. We can also see that the IP address of this machine is 192.168.20.101, which is from the address pool that we have set up earlier. We can even see this in the terminal. If we run the command IP addr show, we can see the IP address and any relevant information. We also need to check the connection to the internet. To do that, we do a ping C4 -C4 8.8.8.8, and we can see that we get a response. 4 packets transmitted, 4 received. This means that we have connection to the internet, and we can even verify this by going to the Firefox browser. And let's say we go to google.com and we search for Cisco. We can see that we get a result and we can navigate the web. Okay, now let's also ping the DNS. Ping C4 192.168.20.1, and we can also see that we get a result on the Ubuntu machine. We go to the Windows machine, we do the same thing. We will go into settings first. We will go to Ethernet again, then we will go down, and we will see that our IP address is from the address pool 192.168.30.100, and we can also see that the DNS server is the one that we have set. Okay, now we'll open up the terminal. And we will do the same thing as we have done on the Ubuntu machine. We will test, we will see internet protocol information. Again, same thing as I have shown in the graphical user interface, but this time in the terminal. We can see the DNS server, the IP. Okay, let's clear this. We test the connection to the internet by doing a ping towards 8.8.8.8. We can see that we get a connection, 4 packets sent, 4 received. We do another ping to the DNS 192.168.30.1, and we also get a reply. We can also verify by going to the web and searching something on Google. Again, Cisco. We can see that we have connection to the internet and we can browse the web. Okay, so now that we have done this, we can go here and we can clearly say that we have connected the virtual machines to the virtual network. and we have checked the connection of the machines. Now what we want to do is to isolate the traffic between the two machines with aliases and firewalls. We don't want these two machines to be able to ping each other, to communicate with each other. And one thing that we can see is that the machines can ping each other. So for example, if I'm on my Windows machine and I do ping 192.168.20.101, which is the IP address of the Ubuntu machine, we can see that I get a response. And this is not the behavior I want. I want this machine to be isolated, to only communicate with the other machine through the internet. Same thing can be said about our Ubuntu machine. We can go ping 192.168.30.1. This will be the LAN, and that is because Windows by default blocks pings from a Linux machine. So I will just do it from the LAN. I will just do a ping towards the LAN. And we can also see that we get a response. So in order to isolate these two machines, we will create a series of firewall rules that will allow internet traffic, but will disallow any traffic from one machine to another. So I will suspend these two guests. I will suspend the two machines. Okay, now the machines are suspended. I'll go inside my browser and we are back. We will go to firewall, then firewall aliases. One second, firewall aliases. And here in aliases, I have created this alias, which I will show to you. Go to edit alias. This alias basically scopes all of the private IP addresses that exist. So we have the biggest network, the second biggest network, and the smallest network, all in this private IP alias. Okay, we will save this, apply changes. Now we have this alias. We will go to firewall, then firewall rules. Then for Linux LAN, we will delete this rule and create two rules. The first rule will be towards allowing any internet traffic. To do that, we go to pass Linux LAN, then IPv4, then protocol TCP UDP. This is to allow any internet traffic. Then we go to source. Source will be Linux LAN subnets. Then destination will be Linux LAN address. Okay, now we will save this. And if we read it from left to right, we can see that for this LAN, any TCP UDP signal can reach any address of this LAN. Okay, now we add another rule for this LAN, but this time for any protocol. We will select Linux LAN subnets, and we will also select private IP and aliases, and we do private IPs, and we do invert match. We will save this, and the order will be as follows. First will be the internet traffic, and then any other type of traffic will be blocked. We apply changes. We go into sorry, the changes have not applied as I wanted. Okay, save. Okay, now it is as I wanted. Okay, we go to Linux LAN and we do the same thing. I will pause the video and come back. Okay, I have set up the firewall rules for both Linux LAN and Windows LAN. The rules are the same. Basically, the first rule says allow any internet traffic, and the second rule says disallow any internal local area network traffic. Now I will put this down and I will resume the virtual machines. I will also resume this virtual machine. Okay, and we can test our firewall rule just by doing the pings we have done before, and now instead of getting a response, we should get no response at all. And we can see right off the bat that we don't get any sort of response of any kind from the Ubuntu machine. Soon it will say that 4 packets transmitted, 4 packets lost, so 100% packet loss. So the packets didn't go through, and we can do the same thing for our Windows machine. Again, pinging, request timed out again, and it will do it 2 more times. We can also test if we can ping the DNS of the Ubuntu machine, and we will get the same response. Okay, but now we need to test the connection to the internet. So we do that by pinging 8.8.8.8, and we can see that we still have connection to the internet. We can also verify that by doing a Google search. Again, Cisco, and we can see we have access to the internet on the Windows machine, and we will do the same thing on the Linux machine. We can see we get a full ping, 4 packets transmitted, 4 received. We can go on the browser, again do a Google search, Cisco, and we can see we have access to the internet. We can browse the web. So now I can check the final step, the final objective of this project, of isolating the network such that these 2 machines can only communicate via internet, not locally. So yeah, thank you for watching, and this has been my project. Goodbye and have a great day.